Download this code from codegive.com, link in the description below. Making debugging faster with Visual Studio and Azure DevOps, a deep dive. Debugging is an inevitable part of software development. It's the process of identifying and resolving bugs or defects in your code that cause it to behave unexpectedly or incorrectly. While debugging can be time-consuming and frustrating, mastering effective debugging techniques can significantly improve your productivity. This tutorial will explore how to leverage Visual Studio and Azure DevOps to streamline your debugging workflow, reduce debugging time, and improve the overall quality of your code. Why optimize debugging? Before diving into the specifics, let's understand why focusing on efficient debugging is critical. Reduce development time. Faster debugging translates directly into shorter development cycles. You spend less time chasing bugs and more time writing new features. Improved code quality. Effective debugging helps uncover hidden flaws in your code that might not be apparent during testing. This leads to more robust and reliable software. Enhanced collaboration. By integrating debugging with Azure DevOps, you can share debugging information, reproduce issues easily, and collaborate with your team more effectively. Lower maintenance costs. Early detection and resolution of bugs reduce the likelihood of them reaching production, which in turn lowers maintenance costs and minimizes disruptions for end users. Tools and technologies covered. This tutorial will primarily focus on the following tools and technologies. Visual Studio. The primary integrated development environment, IDE, used for writing, building, and debugging code. We'll explore key debugging features within Visual Studio. Azure DevOps. A comprehensive suite of DevOps tools from Microsoft. We'll focus on how to use Azure DevOps for bug tracking, test case management, and collaboration during debugging. IntelliTrace, deprecated but discussed for historical context. A historical Visual Studio diagnostic tool that captured a timeline of events during application execution, providing valuable insights into debugging. While largely superseded by newer profiling tools and techniques, its concept is still relevant. Note: IntelliTrace is largely deprecated and unsupported. Live Debugging, Snapshot Debugger. The newer alternative to IntelliTrace, allowing you to take snapshots of your application's state in production, greatly aiding in debugging live issues. .NET Debugging features. Specific debugging capabilities provided by the .NET runtime, such as exception handling, symbol loading, and memory analysis. Key areas for debugging optimization. We'll explore the following aspects of debugging to optimize your workflow. 1. Understanding Visual Studio debugging features. Master the core debugging features within Visual Studio, like breakpoints, watch windows, call stack, and exception handling. 2. Effective breakpoint management. Learn how to strategically use breakpoints to pause execution at critical points and examine the state of your application. 3. Watch windows and data inspection. Use watch windows to monitor variable values, evaluate expressions, and understand the flow of data through your application. 4. Call stack analysis. Navigate the call stack to trace the execution path that led to the current point, which is invaluable for understanding complex function calls. 5. Exception handling and debugging. Configure Visual Studio to handle exceptions gracefully and use exception breakpoints to pinpoint the source of errors. 6. Leveraging logging and tracing. Implement logging and tracing to record information about your application's behavior, making it easier to diagnose issues, especially in production environments. 7. Reproducing issues with Azure DevOps. Use Azure DevOps to capture bug reports, create test cases, and reproduce issues consistently. 8. Snapshot debugging in production. Azure DevOps. Learn how to use the snapshot debugger to capture snapshots of your application's state in a live environment, enabling debugging without stopping the application. 9. Using profiling tools. Visual Studio. Identify performance bottlenecks using Visual Studio's profiling tools to pinpoint areas for optimization. 1. Understanding Visual Studio debugging features. Visual Studio offers a rich set of debugging features. Let's examine the most important ones. Asterisk breakpoints. Asterisk. These are markers you set in your code where the debugger will pause execution, allowing you to inspect the state of your application. Asterisk watch windows. Asterisk. These windows allow you to monitor the values of variables and expressions as your code executes. You can add variables directly or create custom expressions. Asterisk immediate window. Asterisk. This window lets you execute code snippets or evaluate expressions in the context of the current debugging session. Asterisk call stack window. Asterisk. This window shows the sequence of function calls that led to the current point of execution. It helps you understand the flow of your application. Asterisk locals window. Asterisk. This window displays the values of local variables within the current scope. Asterisk autos window. Asterisk. This window automatically displays variables used in the current line and the immediately preceding lines of code. Asterisk exception handling. Asterisk. Visual Studio provides features to handle exceptions, allowing you to step through exception handlers and examine the exception object. Asterisk IntelliTrace Legacy, for historical understanding. Captured historical execution information. While largely replaced by more modern techniques, its principle of understanding the path to an error is still valuable. Asterisk snapshot debugging, modern replacement for IntelliTrace, captures snapshots of the application state in a live environment. Code example, Visual Studio setup for debugging. Explanation asterisk. 1. Setting breakpoints asterisk. In Visual Studio, open this code and click in the left margin next to the line int result equals divide, 10, 0. A red circle, breakpoint, will appear. Do the same on the console.write an error occurred, plus ex message, line within the catch block. 2. Starting the debugger asterisk. Press F5 to start debugging. The program will pause at the first breakpoint you set, the divide call. 3. Stepping through code asterisk. Use F10, step over, to execute the current line and move to the next. Use F11, step into, to enter the divide function. Use Shift plus F11, step out, to return to the calling function. 4. Inspecting variables asterisk. While paused at the breakpoint inside divide, right-click on numerator or denominator and select Add Watch. The values of these variables will appear in the watch window. 5. Exception handling asterisk. The divide function will throw a divide by zero exception. The debugger will automatically break on the exception if you have break when thrown enabled for divide by zero exception. Debug-Windows-Exception settings. 6. Call stack asterisk. While the debugger is paused, open the call stack window, debug-Windows-call stack. You'll see the call sequence, main-divide. 2. Effective breakpoint management. Breakpoints are your primary tool for pausing execution. Use them strategically. Asterisk conditional breakpoints asterisk. Break only when a specific condition is met. Right-click on a breakpoint, select Conditions, and enter a C expression. For example, you might break only when I10 in a loop. Asterisk function breakpoints asterisk. Break whenever a specific function is called. Go to debug-new breakpoint-break at function. This is useful when you want to inspect how a function is being used. Asterisk data breakpoints asterisk. Break when a specific memory location changes. This requires more advanced debugging and knowledge of memory management. 3. Watch windows and data inspection. The watch, autos, and locals windows are crucial for examining data. Asterisk watch window asterisk add any variable or expression to the watch window. You can also modify variable values directly in the watch window during debugging. Use with caution. Asterisk autos window asterisk automatically displays variables used in the current line of code and surrounding lines. A quick way to see relevant data. Asterisk locals window asterisk shows all local variables within the current scope. Useful for examining the entire context. Asterisk immediate window asterisk evaluate C expressions in the current scope using the immediate window. Type variable name to display its value. You can also execute code directly. Example, watch window. While debugging the example code, if you add numerator/denominator to the watch window before it's evaluated, you will see a int does not contain a definition for numerator or type of error. However, once the breakpoint is inside the divide method, F11 to step into, you'll see the actual evaluation and the error in the watch window since denominator is 0. 4. Call stack analysis. The call stack is a powerful tool for understanding how your code reached a particular point. Asterisk navigating the call stack asterisk double-click on a line in the call stack to jump to that location in your code. Asterisk external code asterisk the call stack may contain calls to external libraries or frameworks. You can choose to show external code in the call stack window's context menu. Asterisk identifying recursion errors asterisk the call stack is essential for identifying infinite recursion issues. You'll see the same function repeated many times. 5. Exception handling and debugging. Visual Studio provides extensive support for exception handling. Asterisk exception settings asterisk open debug-windows-exception settings. Configure which exceptions you want the debugger to break on. You can break on all exceptions, specific types of exceptions, or exceptions thrown from a particular module. Asterisk exception helpers asterisk when an exception is caught, Visual Studio displays an exception helper window that provides information about the exception, including the type, message, and stack trace. Asterisk conditional exception breakpoints asterisk break on an exception only when certain conditions are met. This is useful when you want to ignore exceptions that are expected and handled correctly. Example, exception settings. In the debug-windows-exception settings window, search for divide by 0 exception. Check the box in the thrown column. Now, when you run the example code again, with the original breakpoints removed, the debugger will immediately break when the divide by 0 exception is thrown in the divide method. This is before the catch block even executes. 6. Leveraging logging and tracing. Logging and tracing are essential for diagnosing issues, especially in production environments where you can't directly attach a debugger. Asterisk system.diagnostics.trace and debug asterisk use system.diagnostics.trace.rit for tracing information and system.diagnostics.debug.rit for debugging information. Debug.rit statements are only compiled into debug builds. Asterisk logging libraries, Serolog, nlog. Consider using more advanced logging libraries like Serolog or nlog. These libraries offer features like structured logging, different log levels, example debug, info, warning, error, fatal, and configurable log syncs, example file, database, console. Asterisk application insights, Azure Monitor for Azure-based applications, use application insights to collect and analyze logs, performance metrics, and exception data. Application Insights provides powerful tools for monitoring and diagnosing issues in production. Example, Logging with Serolog. First, install the Serolog NuGet package, install package Serolog. Explanation **. 1 Configuration **. The logger configuration sets up Serolog to log to both the console and a file named log.txt. Rolling interval .day means the log file will be created daily. 2 Log levels ** Serolog supports different log levels: debug, information, warning, error, fatal. Minimum level .debug means that all log levels will be logged. 3 Structured logging ** Notice the use of numerator and denominator in the log.warning call. This is structured logging. The values of numerator and denominator will be logged as properties, making it easier to query and analyze the logs. 4 Exception logging * log.error, x, an error occurred during division, logs the exception details, including the stack trace. 5 Log closing * log.close and flush, is critical. It ensures that all buffered logs are written to the output sinks before the application exits. 7. Reproducing issues with Azure DevOps. Azure DevOps helps you manage bug reports, create test cases, and reproduce issues consistently. 1 Bug tracking * when a user reports a bug, create a work item in Azure DevOps to track it. Include as much information as possible, such as steps to reproduce, the environment, and any error messages. 2 Test cases * create test cases in Azure DevOps that specifically target the bug. This helps ensure that the bug is fixed and doesn't reappear in the future. 3 Reproducibility * provide clear and concise steps to reproduce the issue in the bug report and test case. This makes it easier for developers to understand and fix the bug. Consider creating automated tests that reproduce the bug. 4 Environment details * document the environment in which the bug was observed, example operating system, browser, .NET version. Differences in environment can often cause bugs to manifest in unexpected ways. 5 Collaboration * use Azure DevOps to assign bugs to developers, track progress, and communicate about the bug. This ensures that everyone is on the same page. Example, Azure DevOps integration. 1 Create a bug work item * in Azure DevOps, create a new bug work item. 2 Title and description * set a clear title like divide by 0 exception when denominator is 0. In the description, provide detailed steps to reproduce the issue, such as * run the application. * the application will throw a divide by 0 exception. 3 Repro steps * specifically list steps. * open program.cs. * set a breakpoint at int result equals divide, 10, 0. * run the application in debug mode. * step into the divide method. * observe that denominator is 0, causing the exception. 4 Attachment * attach the code file, program.cs, to the work item. 5 Assign * assign the bug to a developer. 8. Snapshot debugging in production, Azure DevOps. Snapshot debugging, using the Azure Application Insights Snapshot Debugger, is a powerful technique for debugging issues in live environments without interrupting service. Prerequisites * your application must be deployed to Azure and integrated with Azure Application Insights. * you need to have the appropriate permissions in Azure to access and use the snapshot debugger. How it works * 1 Triggering snapshots * when an exception is thrown in your application, the snapshot debugger automatically captures a snapshot of the application state at that moment. This includes the call stack, local variables, and other relevant information. You can also configure custom point of interest snapshots. 2. Accessing snapshots in Visual Studio *. You can view the snapshots directly in Visual Studio. When you open a snapshot, you'll see a full debug session, as if you had attached a debugger to the live application at the moment the exception occurred. 3. Debugging in production *. This allows you to step through the code, inspect variables, and understand the root cause of the issue without affecting the running application. Steps to use snapshot debugging *. 1. Enable snapshot debugger in Application Insights * in the Azure portal. Navigate to your Application Insights resource. Under the Investigate section, select Snapshot Debugger. Enable the Snapshot Debugger. 2. Add the NuGet package *. Add the Microsoft.ApplicationInsights.Snapshot Collector NuGet package to your application. 3. Configure snapshot debugging in your code. Minimal required in your program.cs or startup class. Add the following. Important considerations *. Performance impact * Snapshot debugging has a small performance impact. It's designed to minimize overhead, but it's important to monitor performance and adjust settings if necessary. Security * Snapshot debugging can expose sensitive data. Ensure that you have appropriate security measures in place to protect the data. Avoid logging sensitive information directly into variables that would be captured in snapshots. Cost * Snapshot debugging incurs costs based on the amount of data collected and stored. Monitor your usage and adjust settings if needed. Redaction * Consider using the snapshot debugger's redaction features to automatically remove sensitive information from snapshots. 4. Deploy your application to Azure * Deploy your application to Azure. Ensure that it's properly configured with Application Insights. 5. Trigger an exception * Trigger the exception in your application, example by accessing the URL that causes the division by 0. 6. View the snapshot in Visual Studio * In Visual Studio, go to Debug-Windows-Show Diagnostic Tools, or press Alt plus F2. Select Application Insights from the drop-down and connect to your Azure subscription. You should see the exception event in the Application Insights events list. Click on the Open Snapshot link to open the snapshot in Visual Studio. Simplified example, illustrative. Let's imagine the previous debugging example is deployed to Azure and throwing the divide by 0 exception in production. With snapshot debugging enabled, you would 1. Go to the Azure portal - your Application Insights instance. 2. Search for the exceptions thrown, typically using the Failures section. 3. If a snapshot was captured, due to the exception occurring, you'll see a link to Open Snapshot in Visual Studio. 4. Clicking this will download the snapshot and open it within Visual Studio. You can then step through the code exactly as it was executing when the exception occurred, examining the values of numerator and denominator at the point of failure. Benefits of snapshot debugging. Debug live issues * Debug problems in production without stopping the application. Reduced downtime * Quickly identify and resolve issues, minimizing downtime. Improved diagnostics * Get detailed information about the application state at the point of failure. Simplified debugging * Simplify the debugging process by providing a snapshot of the application state. 9. Using profiling tools, Visual Studio. Visual Studio's profiling tools help you identify performance bottlenecks and areas for optimization. CPU usage * Identify functions that consume the most CPU time. Memory usage * Detect memory leaks and excessive memory allocation. .NET performance * Analyze .NET specific performance metrics, such as garbage collection frequency. Steps to profile your application asterisk. 1. Start the profiler asterisk in Visual Studio, go to Debug-Performance Profiler, or press Alt plus F2. 2. Choose Profiling Tools asterisk select the profiling tools you want to use, example CPU usage, memory usage. 3. Start collection asterisk click Start to begin collecting profiling data. 4. Run your application asterisk run your application and perform the actions you want to profile. 5. Stop collection asterisk click Stop to stop collecting data. 6. Analyze the results asterisk Visual Studio will display a report with the profiling data. Use the report to identify performance bottlenecks and areas for optimization. Example, CPU usage profiling. 1. Start the performance profiler, Alt plus F2. 2. Select CPU usage. 3. Click Start. 4. Run the debugging example program. Even though it's a very simple program, if you had a more complex application, you'd exercise the areas you want to profile. 5. Click Stop. 6. The CPU usage report will show you how much CPU time was spent in each function. Conclusion. By mastering these debugging techniques and integrating Visual Studio with Azure DevOps, you can significantly improve your debugging speed, reduce development time, and improve the overall quality of your code. Remember to use breakpoints strategically, inspect data effectively, leverage logging, and take advantage of snapshot debugging for production issues. By continuously refining your debugging skills, you can become a more efficient and effective software developer.